Here we go, ladies and gentlemen, welcome back. This lesson's on the radical system, the radical system package. And as a preamble, a lot of you already know where we're leading to. It's obviously related to the quadratics that you were taught in grade 10. And so what we did in grade 10 is reviewed this concept of a mixed radical, vice versa to the entire radical. And this is the concept of a mixed radical. This is the radical sign, and underneath it's called the radicand. And that's called the entire radical. A lot of you know this as an exact answer, So we're not using like decimals. A mixed radical has a coefficient usually, or a number, and a radical component. Now how do we change it to? Well, a lot of you learned this rule. The square root of AB is equal to the square root of A times the square root of B. And usually the hint is try to find the largest perfect number, right? So in this first example, example 1, the first one here. How do you actually say this? First of all, it's the square root of 75, or root 75. And by and large, not all of them can be changed to mixed radicals, right? This is obviously a special one. And so I'll teach you how I teach my students. You think of the largest perfect number that goes into 75. Well, what's perfect numbers? Perfect numbers are as follows: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and then I think 169 is probably the best way to go. Don't get me wrong. The argument is all numbers are perfect numbers because then you can do the radicals, but these are the perfect numbers, or perfect squares. A lot of you know this. And so the largest perfect square that goes under root 75, anyone know? Really easy, Jen.
25.
Sure, so show me intermediate step. Again, a lot of you already know how to do this, ladies and gentlemen, but this is for those people, this is for fresh. It's root 25, and so what you're doing is thinking of a number that makes up that product, right? So root 25 times root 3. And the final answer is, well, the square root of 25, a lot of you know from the perfect numbers that I wrote here, it's 5. Notice when we're evaluating, we tend to only get the positive answer. So the final answer, notice this is a mixed radical called 5 root 3. That's how you say it, 5 root 3. It's almost analogous to this example, a mixed fraction. This is 5 and 1/3. However, what's happening between the 5 and the root 3 is multiplication, and what's happening between the 5 and 1/3 in this case, it's actually addition. So that's why, that's the commonality where the election by. Okay. Let's erase that. Let's try question B. Question B is root 48 over root 6. Now, I'll be honest with you, there's also another radical rule that's actually in this package. We didn't actually stress, I think, in grade 10, and so we're just going to copy it out. You can actually break a square root of A over B is equal to root A over root B. And we have to put this disclaimer here. A must be greater than or equal to 0, and B must be greater than 0. So notice the inequalities there. Now, maybe you don't realize it, but these two rules, and let's highlight them in orange. These two rules, they're actually exponent rules. So you may or may not have taught that in grade 10. So that's actually, there is a connection, and we'll explain that more when we get to the exponential functions. But as it stands, we have root 48 over root 6. So I think some of you realize there's many ways actually doing this particular question. Okay? So some of you might actually break up this root 48 into two products, and not necessarily actually gives us the answer. Any volunteer want to help us out? Again, this one's pretty easy. Dinesh?
I guess you divide 48 by 6.
Yeah, so you're doing it like this. See, I actually don't think of it this way. I actually don't use this rule. This is letting you know, ladies and gentlemen, I don't think of this. It's just my weirdness. But you are correct. You're just translating it, which is fine. And it reduces down to?
8.
I think root 8, right? And then, sorry? 2 root 3 is correct. Notice, let's go into intermediate step if that's okay. Root 4 times root 2. I thought this is bad math, but I'm running out of room. 2 root 2. Everyone okay with that? These two examples? I'm not going to do the example C, if that's okay. Let's go with the reverse. Can I erase this still? Does someone still need this? And again, these are all the PowerPoints that are also associated. I just try to teach it to you so that you guys can see these steps. And then they might not be identical, right? Can I erase this? Example 2. We're going the reverse. Giving mixed radical, let's go into entire radical. So let's just do 2 examples here. Example 2, 2a. Again, the way that you say this is 4 root 2. 4 root 2. So going the backwards, I think a lot of you realize conceptually you square this number and then put it on the radical sign. So I think 16. 2, and then combine it. Anyone want to help me with mental math? 16 times 2, no pressure. Jasmine? 32. Root 32. Everyone okay? So they're equivalent. 4 root 2 is the same thing as root 32. Let's just do one more. Let's do question C. Let's just see. Question C is 3 root 5 over 2 root 7. And again, many of you might not have done this in grade 10, so don't feel bad. A couple ways of doing it. Any volunteer want to start us off? You can do it slowly. Any volunteer want to start us off? Jasmine, want to try?
The numerator would be root 9 times root 5.
Sure, so what Jasmine's doing, ladies and gentlemen at home, she's changed the numerator from 3 root 5 to root 9 times root 5. And what would you do to the denominator, Jasmine?
Root 4 times root 7.
Before we continue, everyone okay? This is fine, I don't mind, I think this is okay. And I think we're going to get root 45 over root 28. That's an ugly 8. Looks better. Can we reduce that still? Can we reduce that still?
Are you supposed to make the denominator like not a radical?
Yeah. Well, that's an example 6 actually, I think. But okay. I think they wanted this as a final answer 45. I think that's what they wanted. Just change it to an entire radical, right? Okay. Any question about example 2? So that's going from mixed radicals to entire radicals and entire radicals to mixed radicals. Let's get to example 3. Can I erase this? And again, the PowerPoints are there. We're just walking through it. Thank you, by the way, Jasmine. And what Jasmine brought up is understanding about rationalizing. We'll talk about that in a moment, but I think that's an example 6. Example 3, again, I don't know if you actually looked at these. These are actually now manipulating using order of operations. So once again, we'll just do the first example. We have 9 root 2 times 4 root 7. And because it's multiplication, it's commutative, you can multiply in any order you want. But most students will multiply the 9 and the 4 first, and then the radicals. So I'll just show you how I think of this question. 9 times 4, that's easy, it's 36. And then root 2 times root 7 is root 14. And then sometimes you still check, just in case, the root 14. Is there anything that could, like if there's a perfect number in there? And the answer is no, I don't think. So I think this is the answer they want. And you could, in theory, give me the entire radical, but the mixed radical tends to be a little bit more efficient. And again, using your calculator, how would you write this in? a lot of you realize you just type it exactly how you see it. 36 is the square root of 14. And if you have the sharp calculator, it will understand what that is. So we're now to example 4. And notice in the handout, and I'll read this to you, to simplify radical expressions, express radicals in simplest radical form and add or subtract like radicals. So this is again why we had to actually practice with algebra, just to make sure you know how to collect like terms. Let's do the first example together. We have root 12 plus root 18 minus root 27 plus root 8. And if you look at this, ladies and gentlemen, it almost looks like there's no like terms. It's like, well, none of them are alike. However, I'll do this one if that's okay. I'm going to change them into mixed radicals. But when we change them to mixed radicals, we're trying to get them reduced as much as possible. So I'll take an intermediate step. Some of you do this in your head, and that's fine. But I'm going to do this one nice and slowly. This is root 12. So the numbers, although 6 times 2 is 12, the largest perfect number is 4 that goes in there. So I'm going to get square root of 4 times the square root of 3. And again, I'm just going to go this slowly. You don't have to copy this one down if you don't want to. For root 18, I think everyone agrees that you can use 6 and 3. But I'm going to use square root of 9, square root of 2. For this negative root 27, I'm going to use 9 and 27. 9 and 3, I'm speaking. And last but not least, that 8 is going to be root 4 times root 2. So a lot of you are saying, it doesn't really matter which one is the perfect number, but most of you, ladies and gentlemen at home, most of you use the square root of 8 to be the largest perfect number. Before we continue, everyone okay? So then we do the next step. We get 2 root 3 plus 3 root 2 minus 3 root 3 plus 2 root 2. And again, to collect the like terms, this 2 root 3 and this negative 3 root 3 are like terms. And this positive 3 root 2 and this positive 2 root 2 are the other like terms. And when collecting like terms, we simply add or subtract coefficients. So 2 take away 3 is negative root 3. We tend to ignore the negative 1, but you can put it in, but that's a little silly. And then 3 root 2 plus 2 root 2, that is 5 root 2. And actually, this is the final answer. It doesn't look pretty, but it has been simplified as much as possible. Technically, you could also have written like this. 5 root 2 minus root 3. They are analogous, but I'm just writing it in the order how I see it, and it doesn't really matter, and it would be acceptable. Okay. I think example B you can do on your own. This is a little bit more complicated. But any questions about this example 4A? Ted?
If we don't do the first step.
This one?
Yeah,
you can go to this one right away.
Oh, okay.
Yeah, absolutely. So again, ladies and gentlemen at home, then Ted is asking, if we don't do this first step, can we just go to here? Absolutely. I would like to see this before you get to this. Okay. Now, technically, ladies and gentlemen, the higher quality calculators, like the Casio, the better sharp calculator, if you enter this in, it'll evaluate to an exact answer, either one of these answers. That's why we do not allow those calculators when you're doing the test. That's why you have to have the sharp one. It's not saying you can't check your answer though, right? If you enter this in, you'll get a decimal answer because it tends to give you a real answer. So you can verify your answers and just checking the not exact answer, but the approximate answer to see if it is correct. And that's how I would check my answer, just to make sure I did it right. Does that make sense? And if you want to know more, you can definitely ask me in extra help. Any other questions before we move on to example 5 and example 6? So example 5, and hopefully I can erase this backward. Seems like a long day. In example 5, it says, well, first of all, the hint above, to multiply binomial radical expressions, use the distributive property and add or subtract like radicals. So we'll just do two examples. I'll do A and B. Hopefully everyone's following along. Notice again in our algebra grade 10 review, I did not review how to multiply monomials or divide monomials and hard monomials. So I think you guys are understanding what we're doing. Hopefully I answered that question, right? Again, how would you say this to somebody? You have 3 root 2 times 2 root 6 plus root 10. And so just, you don't have to show this, but letting you know what we're doing. We're distributing that, we're clearing that bracket and we're multiplying. So again, one more time, I would actually go this slowly, especially with radicals, because it's a little weird. Don't get me wrong, some of you actually do it in your head, but I'll just do it the long way. 3 times 2 is 6, that's the coefficients, and root 2 times root 6, that's root 12. And then we rinse and repeat. 3 times 1 is 3. And then root 2 times root 10 is root 20. And this is a good answer, but it's not simplified as much as possible. And then watch carefully what I'm going to do. I'm just showing the coefficients here, the 6 and the 3. That root 12, and again, this is what Ted mentioned. If some of you can do this in your head, that's great, but just to help you with the lesson, root 12 is actually made up of 4 times 3. And root 20, can anyone help me out in the class?
4 times 5.
4 times 5. And again, the 4, don't get me wrong, you can say 5 times 4, you can say 3 times 4, respectively, for those two parts. But a lot of you understand what we're trying to do. We're trying to take a perfect number out. And again, still, some of you take your time here. And that's why I try to explain the multiplication. 6 times 2 is 12. That's 12 root 3 plus 6 root 5. And I think that's the answer that we're looking for. And we can't go any further. So one more time, the final answer for question example 5a is 12 root 3 plus 6 root 5. Any question about that one? Not second last, but the last one for this example, we'll do example B, and I'll leave question C for you. And figure out your own. So we have a binomial here. 3 root 2 plus 4 root 5 times 4 root 2 minus 3 root 5. So we're going to FOIL this, nice and easy, expand this out. So 3 times 4 is 12. And then we're going to, root 2 times root 2 is 4, which is of course 2. We're going to repeat, minus 3 times negative 3 is negative 9. And then that's root 10. Plus 16 root 10. And then negative 12 root 25, which of course is 5. So again, I'm just showing you my intermediate step. That's okay, ladies and gentlemen. We're not done. But then that's 24. And then negative 9 root 10 plus 16 root 10, those are like terms. And I think that's 7 root 10, right? And then that's negative 60. Tell me how 24 minus 16, what is that? Yeah, Jasmine?
Negative 36.
I think so, negative 36. And I think that's the answer. Or if you're like this, 7 or 10, that's also fine. But I think that's the answer we're looking for. Let's just check if I'm right. What's that? Yeah, 7 or 10. Any questions on what we just did so far from examples 1, 2, 3, 4, or 5 before we get to example 6? Today's lesson. I'm probably going to end early, but we're just going to let you chill out and Stick around. Any questions in the class? And again, you at home, you probably don't know what we're doing. Cohort B is the best. I'm kidding, I don't know. I'm proud. Fiona looking at me, what the hell? Can I erase this? Example 6. The whole reason why we're doing this. Example 6 talks about what's called rationalizing the denominator. In mathematics, mathematicians actually don't like seeing radicals in the denominator. They don't like that. And so, what they're trying to do is just basically get rid of it. So you see above in the handout, it says recall, blah, blah, different the squares. And they actually give you an example there. And then the conjugate binomials. I'm not going to go through that just yet. A lot of you will hopefully understand what that means. And again, your textbook actually has it, I think, in there. You just have to find it. I can't remember exactly what section it is of the radicals. But it'll make sense when I do at least maybe 2 or 3 of these examples. I think some of you might have done this last year. I don't know. I can't lick my fingers. So there's only 4 examples, but I'll only do 3 of them. So the first one is 1 over root 2. And again, it's basically like changing this fraction to an equivalent fraction. That's all you're really doing. So in order to get this rid of the square root in the denominator, because that's what you want to do, you probably want to multiply the numerator denominator by the number 1. But not just any one. This one, root 2 over root 2. So this is an easy one because this is actually a monomial. And so this one's going to get rid of it. So notice what I said, ladies and gentlemen. Although in mathematics, we don't like having a radical in the denominator. Radicals in the numerator? A-okay, it's all good. So let's just be a little cheesy. 1 times root 2, that's root 2. Root 2 times root 2, we'll just cheat this out with 4. And the square root of 4 is 2. And that is the answer. So this is called a rationalized answer of 1 over root 2. It's the same. It looks different. And again, one more time, if you wanted to check your answer with your calculator, you can do 1 divided by the square root of 2, get the decimal answer for that. It'd be the same as root 2 divided by 2. Right? Have you guys actually learned this in grade 10? Some of you. So let's do example C. C is this one. Negative 3 over root 5 plus 2. Now notice, again, in the denominator, we have root 5 plus 2. And in this case, the denominator is a radical sign and it's actually a binomial. There's 2 terms in there. So, ladies and gentlemen, to rationalize this, we're not going to simply just use this one, because that's a monomial, it's 1. But in this example, we're going to use this. We're going to multiply by, not just any one, but root 5 minus 2 over root 5 minus 2. And the relationship between root 5 plus 2 and root 5 minus 2, they're called conjugates. Conjugates. A lot of you realize one of the signs will be positive, the other will be negative. So when you look at the above instructions, it's actually just telling you what to do. Conjugates always come in pairs, so there's always going to be a positive and or a negative. Back to this. Why is this important? Unfortunately, we can't divide anything out in this example. So with fractions, we're going to simply multiply all the numerators. So negative 3 times root 5 is negative 3 root 5. And negative 3 times negative 2, that's positive 6. That's the answer in the numerator. But in the denominator, and again, if you need a hint, look above in the box, this is actually a difference of squares. Root 5 times root 5 is root 25, but square root of 25 is 5. And then 2 times negative 2 is negative 4. And notice, I don't need to worry about this, even though a lot of you realize we could be foiling. The 2 terms in between, the 2 root 5 and the negative 2 root 5, actually cancel. That's why this is actually a difference of squares. We expand it. We're not done yet. 5 minus 4 is 1, and that is actually the answer for this. Before we continue, everyone okay? So there was actually no denominator in this example. This time we're going to need some class participation for this last example, example D. In this case, we have 5 over 2 root 6 minus root 3. And then I pause, let's see if the screen is still capturing. Yeah, I think it's okay. Let's make that bigger. Slightly over. This is our last example. This time, can I get a volunteer from the class? We're going to multiply by 1. But we're going to use a conjugate. Name volunteer. Dana, you want to try?
Is it 2, 6 plus 3?
Yeah. Over 2 root 6 plus root 3. And again, for those students, don't get me wrong, don't feel bad. Because again, I don't think in the regular grade 10 class we really talk about rationalizing. Again, the denominator is the binomial that we're trying to get rid of those radicals. And this is the only way to do it. Is multiplying by 1, not just any one. This particular one that Patina said, right? So let's see if someone actually help us out for the numerator. Thanks a lot, Patina. Dinesh, want to give us the numerator? 10 root 6 plus 5 root 3 is correct. Nicely done. Different volunteer for the denominator. Don't feel bad if you get this slightly weird. It's actually, the reason why it's hard, let's not talk about it. It's not because it's root 6 or root 3, it's 2 root 6. So you might do some mental gymnastics. Jasmine, want to try?
Would it be 24?
I think it's 24 because 2 times 2 is 4. And then root 6 times root 36, which is 6. So 4 times 6 is
4 times 6?
It's 24. Is that what you said? That's what you said, right? I'm pretty sure. I'm just trying to help the people down at home. Anyways.
And then minus 3.
Yeah, because it's root 9, which is minus 3. And then I think the answer is 21. Is that right?
Sir, I have a question.
Sure.
Isn't the top part, like, instead of 2, 6 plus 3, 2, 6 plus 5?
Did I do something wrong?
Like the.
This part?
Yeah, shouldn't the 5 be multiplied and the both radical?
Yeah, so 5 times 2 is 10.
Oh, sorry.
And then 5 times that root 3 is 5 root 3, which is what Tanish said.
Yeah, I didn't see that.
It's okay. Everyone okay? So to recap, ladies and gentlemen, what we looked at for this lesson, for radicals, changing back from entire to mixed radicals and vice versa, how to do simple collecting like terms and multiplying of radicals, and finally rationalizing radicals. And that's why I think, ladies and gentlemen, the rest of the period for you, let's just stop this video.